Good morning, everyone. On behalf of the ISO, we'd like to welcome you to today's Technical Gas Resource Management Workshop to discuss tools for gas system reliability. My name is Christina Giemer, representing ISO Stakeholder Affairs, and I will be facilitating today's meeting. Just a reminder that today's call is being recorded for informational and convenience purposes only, and any related transcription should not be reprinted without the ISO's permission. Please keep your comments professional and respectful. As you may have noticed, there are some new features on the WebEx. The raised hand icon is now directly at the bottom of your screen. And if you joined audio only, please press *3 on your device. There's also a new Inteller transparency view at the bottom right to see other attendees on the call. Be sure to refresh it prior to viewing. And closed captioning is also now available by clicking the CC button on the bottom left of your screen. And as always, please remember to state your name and affiliation first before making a comment. And you can also send comments and questions via chat to all panelists or directly to myself. And if you need any technical assistance today during the meeting, please send a chat to Inteller Events, the host. So with that, I will now introduce Sylvie Spuick to get us started.
Thank you, Christina. So today's workshop is in direct response to some questions and comments that we heard from stakeholders during the working groups and in response to the issue paper. We heard from stakeholders that most stakeholders support developing tools that can help either individual resources or a group of resources manage periods when they face gas burn limitations and manage these periods more efficiently. Multiple stakeholders suggested that there might be a reliability risk related to managing gas burn limitations, and that this can arise when illiquid intraday trading prevents a gas resource from securing additional nominations to meet day-ahead or real-time commitments. And some stakeholders cite risk that incremental dispatch due to mitigation might force a resource to violate an operational flow order from the pipeline. We also got some questions from stakeholders around what the goal of policy development would be in this area. Do resources expect to have to disregard pipeline instructions, and do resources face unavoidable reliability risks during OFO periods? So to address all of these questions and get the ball rolling around policy development, we wanted to clarify two types of problem statements. First, market participants are able to meet commitments and respect gas pipeline instructions, but take on a financial risk to do so if their reference levels are too low. In another scenario, market participants may not be able to meet dispatch instructions without violating pipeline instructions. So in today's presentation, we took all of this feedback and put together a workshop to answer what our expectations are of market participants in these scenarios and identify opportunities to develop new rules or tools to help you manage them. So hopefully after today's workshop, we will have clarified the ISO's expectations for market participants during periods of gas system limitations, and we'll be looking for stakeholder feedback to help us identify gaps where new rules may be appropriate for unique circumstances. We'll also spend some time discussing how the ISO's gas nomogram constraint might work for regional entities, and we'll be looking for stakeholder feedback on the proposal that we put in the gas resource management straw proposal. Finally, our goal is that all of this will help set the stage for continued consideration of the new tools recommended by stakeholders during the working group process. We've got a great agenda today, and I have a number of colleagues with me from across the company to help us out. First, we'll spend some time talking about expected behavior during periods of gas system limitations. I have Sean Grant from Operations Policy with me, and he is in charge of all things gas electric coordination. Next, we'll do a deep dive on gas nomogram constraints, how it works today, and offer a perspective on what this procedure might look like for extended use in the EIM and EDAM. To support that discussion, I will have Sean Grant on deck as well. And from market analysis, Abhishek and Mahir will be joining to talk about the implementation of the gas nomogram in the market and review some data. Finally, to support the gas resource management straw proposal or additional solutions that stakeholders want us to consider, I'll be joined by Andrew Ulmer to talk about questions from the prior FERC order and the proposal objectives that we put in the straw. So let's dive in. Expectations during gas system limitations. These are our broad expectations. On this slide are expectations that you'll find as standard practice across centralized electricity markets and are ideas that have been reinforced by FERC precedent over the years. Resources are responsible for managing their fuel supply through proper bidding and contracting. Resources should follow gas pipeline instructions intended to support system reliability. The corollary to this is that we want to make sure our market design does not negatively impact gas system reliability. Finally, resources are responsible for taking appropriate action in response to gas system limitations to ensure meeting commitments and/or offering incremental energy does not result in unauthorized gas use. In other words, resources are responsible for making sure their energy offers are deliverable. Now, how do we support your doing that? The first line of defense is gas-electric coordination. Gas-electric coordination is the keystone that supports reliability, and one of the ways that we do that is through information sharing. For example, gas pipelines publish information publicly about the conditions on the pipeline, and the ISO also publishes daily operations to support awareness. We review all the different gas pipeline daily reports, and we make available to gas pipelines D1 and D2 estimated gas usage reports, which form the basis for gas curtailment events. Yesterday, we got a question from Stuart Kelly around the coordination that the ISO does or might do with regional gas entities. So I will turn it over at this point to Sean Grant, who can talk more about that.
Sylvie. Yes, I believe Stuart's question regarding, do we get something regarding OFOs, if I remember correctly. The information we get regarding the OFOs is directly from the gas pipelines bulletin boards. So that's the information that we're getting from them. But if you're able to read into some of the pipelines' different data that they send out there, you can see where they're at regarding their pipeline status. For instance, I will use PG&E gas. If you look at them, they actually have a publicly available email they send out every day to tell them where their system is at and where they are regarding an OFO potential. So that's just one example. But as Sylvie mentioned, I do monitor both international, Canada, and Mexico pipelines, as well as interstate and intrastate pipelines. And that information I get from the bulletins I provide to our operations to let them know what system conditions are happening. When it comes to the daily reports, we have NDAs with the interstates, PG&E, SoCalGas, and Kern River, where they get gas burn reports on a daily basis after the D1 and D2 have been published to help them set their system up for the next day. Hopefully that answers everyone's questions. Thank you.
I know we've gotten questions in the past around gas-electric coordination and information sharing, so I just want to pause for a second and see if there are any questions from the attendees.
I'm not seeing any questions coming in at this time.
let's soldier on. Market participant expected behavior in response to physical limitations. Under normal conditions, resources are expected to notify the ISO of fuel supply concerns by submitting an outage card to the extent that fuel is unavailable or a derate for insufficient fuel supply. For outages, the ISO's policy is that once these outages are made public by the gas company, generators are responsible for submitting the plant level limitation through the outage management system so that we can reflect that in the market. There could be conditions that are not considered normal conditions, or as otherwise defined by the gas pipeline, where we might follow procedure at the direction of the gas pipeline. Gas-electric coordination is also integral to establishing capabilities necessary to maintain reliability. So this might be under conditions not considered normal conditions. What actions are appropriate in reliability events may be a function of coordination and defined procedure between relevant entities like the gas pipeline, the BA, the reliability coordinator, and the ISO. So this group of entities might come up with a procedure to define physical gas limitations like service disruptions or curtailments due to reduced gas pressure, pipeline breaks, loss of equipment, or natural disasters. And depending on the circumstances, the ISO may follow a response plan defined in the operating procedure. And I wanted to point this out because we've heard a lot of stakeholder feedback around defining rules to provide more flexibility during operating emergencies like cold weather conditions or extreme weather conditions. So I wanted to point out that we have gas-electric coordination efforts that are intended to define procedure in those conditions. All right, expected behavior in response to gas pipeline instructions for managing gas system imbalances. We understand that limitations on imbalances do not necessarily indicate that there's a physical limit on available fuel supply. In fact, not all OFOs are made equal is something that I've heard. They may mean different things for different pipelines. But the basic definition here is that imbalances might arise when scheduled nominations differ from actual gas usage. So our expected behavior in OFO conditions might depend on when the notification is issued, either day ahead or during the next day gas day versus the same day gas cycles, or depending on a resources specific situation. How much of that, how far there are imbalances outside of their existing nominations, what their balancing agreements with the pipeline might look like, or access to alternative fuel sources. And importantly, expected behavior may differ across regional pipelines, and ISO policy is to give deference to those pipeline instructions. So different pipelines have their own policies and practices that can differ in terms of timing and frequency of notifications, degree of limitations being imposed, penalty structure, and expected behavior as a result. All of which is to say, it's not a straightforward effort to define a single rule or set of rules for market participants to manage imbalances that would apply equally and appropriately across the market. I do want to point out, though, that this doesn't mean we can't do this. Other markets do have unique rules for pipeline practices and exceptional circumstances. It just means that if we want to develop and implement rules that diverge from the standard practices that we're talking about today. Doing so would may require explicit authorization from the pipeline, and at the very least would start in the gas-electric coordination space. And of course, any new rules that we come up with would have to be vetted through the stakeholder process. So in the next couple of slides, I'll talk about what the ISO's expectations of market participants are during OFO conditions, and how to reflect that in reference levels. This is based on the ISO's experience with gas pipelines serving the CAISO BA. In other words, based on our understanding of gas pipeline rules and expectations for the CAISO BA. But again, if gas pipeline rules and expectations differ elsewhere, there are opportunities to talk about how we might accommodate that. But starting off with just a benchmark of our expectations today. Day-ahead participating resources are expected to reflect the cost of managing OFOs through day-ahead energy offers. The ISO, as Sean mentioned, the ISO shares information to day-ahead and day-ahead electric generator gas usage reports with intrastate and interstate gas pipelines. And this helps with gas planning and situational awareness, and also helps gas pipelines manage system constraints in a timely manner. For example, this is one of the reasons why we see OFOs come in during the next day gas day. And the IXO expects that gas indices during the next day gas day would reflect the change in demand for nominations because of that OFO. In turn, we expect that gas indices inform market participants' economic participation in the day-ahead market, and also are used by the ISO to inform reference levels. And a question I wanted to pose at this point to stakeholders is, when does a day-ahead OFO pose a physical limitation? In our experience, the ISO understands that OFOs issued during the next day gas day, while gas is still trading, does not pose a physical limitation. So we're looking towards stakeholders to give us input on whether or when, under what conditions, an OFO issued during the next day gas day can pose a physical limitation. And if nobody wants to tell me now, that's okay. But we have heard stakeholders request some solutioning around this, and we're looking for input to inform the applicability of these tools in the day-ahead market. So I'll move on to real-time. Expected behavior for real-time participation. For resources with day-ahead commitments, the resource is expected to meet those day-ahead commitments, including commitments to offer into the real-time market for periods with AS or RUC awards. If a resource cannot secure enough gas to meet day-ahead obligations and no alternative fuels available, they should take an outage. A resource is only expected to offer incremental energy above commitments or above the base schedule in real time if an OFO, during an OFO, if it can meet those existing commitments and follow incremental dispatch instructions. In other words, if you have a commitment for 5 p.m. and you're worried that incremental dispatch would mean you can't follow through with that commitment, it is your responsibility to figure out how to manage meeting the commitment.
We did just get a raised hand from Darren Anderson.
Darren.
Appreciate it, Sylvie. Me again. And if we could roll back and take a look at the day ahead OFO physical limitation question. I was looking through this on the fly, and so I was multitasking, so I was only halfway listening, but I was listening, so that's good. There is a physical limitation, and I think it needs to be defined what an OFO actually is. OFO means different things on different pipelines, right? So there's contractual OFOs, there's must-flow OFOs. They typically come by tariff requirement, by evening cycle notification for next day. So when the question asked, does a day-ahead OFO pose a physical limitation? The answer is unequivocally yes, it does, because you're talking about something that comes out for evening cycle where physical gas is limited by nature because you've already passed timely and you're moving into that later evening for next day gas period, which is normally in the Pacific Northwest and Northwest Pipeline, which we are familiar with, where our assets lie, most of our assets do, is when that tariff requirement is. And so the must flow obligation or contractual obligation oftentimes has to do with displacing compressed meter stations that are constrained, compressor stations that are constrained. So you're buying gas from point A to point B to counterflow against the standard flow in order to alleviate that potential constraint and allow for delivery of firm transport. And so that's called upon pro rata across many shippers. And so I guess when I say this, there definitely is a physical limitation by the nature of the timing and the obligation of the timing of the transporter to provide for the shipper on when they have to comply to an OFO as it is called on by the transporter. Does that make sense? I know there was a lot there and it probably needs to be unpacked and talked about, but I wanted to make that notation. And I think a lot of folks maybe recognize an OFO is more of an entitlement, what we call an entitlement, where you get hit with a percentage requirement where your load and your gas have to be within a certain tolerance of each other in order to avoid penalty. And that's just not what that means in reference to how bidirectional pipes work in the case of Northwest Pipeline. And there are others out there. I'm just referencing that because that's our home and where we live and breathe. So anyways, I'll be quiet. Maybe that will spur someone else to chime in and have some conversation regarding this. But this is a very important topic, in my opinion, understanding it, managing it, and making sure that we do realize, what stakeholder input and risks are out there, need to be identified and managed. So thank you.
Thank you, Darren. I agree that it would be great to have the opportunity to learn more about that and unpack that more. What I heard is that, well, first, thank you for pointing out what the CAISO's experience is generally with an OFO is that it's a notification from the gas pipeline to a resource to stay within a tolerance of nominations. And what I'm hearing from you is that there's different types of notifications or even contractual obligations that might be unique to, say, a bidirectional pipeline that we need to be cognizant of and understand that different rules there might be applicable. Maybe I'll follow up with you and rope Sean in so that we can talk about this more. Sean, do you have any comments on that?
Sorry about that. It was no, that would be great if we could sit down and discuss that a little bit further. That would be fantastic. So thank you for bringing that up.
Not hearing other brave souls to jump up right now. I'll keep moving on, but feel free to jump in at any time. Real-time expectations. Okay. Hot topics. When can a resource reflect in reference levels during OFO conditions? Asking this question because many stakeholders recommended that the ISO consider a methodology or a way to update reference levels with the economic or reliability impacts of OFO conditions. So as a baseline, it needs to be pointed out that resources cannot update reference levels to reflect or recover OFO penalties. I understand that not all OFOs or conditions in which there is some obligation to limit gas usage come with a penalty, but our general expectation is a little bit more straightforward. In response to limitations on withdrawals, we expect that resources reflect the prevailing cost of securing whatever additional nominations are needed to support dispatch and stay within their tolerance. So talking about this a little more in depth, here's what expected practices for day ahead reference level adjustments. When an OFO is issued, the ISO expects that gas indices will reflect the change in demand for nominations. And the ISO has observed that OFOs issued day ahead are generally captured in those next day gas indices, which the ISO uses to inform reference levels. Now, I understand that this may not be true for all regional pipelines, but we'll get to that in a couple of slides. So in general, for day-ahead reference levels and based on our experience with CAISO BA pipelines, the ISO generally expects that day-ahead reference levels already reflect the impact of managing OFOs during the next day gas day, which means that a resource can request a cost adjustment to reflect the prevailing cost of fuel when those costs differ from the default index in their reference levels, which effectively captures the financial impact of managing OFOs. But the key is that the cost adjustment is based on the prevailing cost of fuel. In real time, the gas index used for real-time reference levels is the next day gas index, typically by default in variable cost DEBs and in the proxy commitment cost calculation. And because we use the next day gas index in real-time reference levels, they may not reflect the impact of OFOs that are issued in real time. So the standard solution is that resources can request a cost adjustment to reflect the cost of incremental nominations same day through the automated process. That means a cost adjustment would get validated up to the reasonableness threshold. So insofar as OFOs have a price impact within the reasonableness threshold, you can request a cost adjustment through the automated reference level change request process. You can also use the manual process if the prevailing cost of fuel does not correlate with the next day gas index in your reference levels. For example, if you're getting fuel from a different source entirely. Now, stakeholders have identified challenges with this standard or expectation. For example, intraday volatility can impose costs outside of the range of the reasonableness thresholds, and at that point it might be too late to use the manual reference level change request process. We've also heard that intraday illiquidity can prevent useful price formation, and the ISO does rely on price formation to inform reference levels. Worst case scenario, it could also make incremental nominations prohibitive. Because we've heard these things in the past and through the working groups, I wanted to quickly talk about the applicability of existing and planned tools. Existing and planned policy is supposed to give resources more flexibility to reflect the impact of gas system limitations on the cost of incremental fuel supply. Again, we expect that if you want to capture these conditions in your reference levels, the thing that you're capturing is the prevailing cost of fuel. So to help you do that, we have a few existing policies that can give you more flexibility in real time. There are certain things that will trigger for the ISO to update real-time reasonableness thresholds under certain conditions. For example, when we observe same-day prices are trending more than 110% of next-day gas indices, we will take the new observed price and recalculate the reasonableness threshold in real time. So if prices are trending higher than the same day than what can otherwise be accommodated, we will give you more flexibility. If the ISO receives 3 manual reference level change requests at a gas hub, that indicates to us a potential supply disruption. And when that happens, we will recalculate the reasonableness threshold for all resources at that hub. So these two existing policies are intended to give you more flexibility to request cost adjustments for the prevailing cost of fuel when it differs because of, for example, supply limitations or needing to get incremental nominations. We've also proposed some things through the Gas Resource Management Straw proposal that are intended to provide more flexibility when it's appropriate, and importantly, both day ahead and in real time. That's important because we've heard from market participants that they anticipate experiencing OFOs in real time or do so on a regular basis and might want to capture that in day ahead offers. So the ISO is proposing to increase the reasonableness threshold for both day ahead and real time when we observe more forecast uncertainty going into the D2. That indicates to us more uncertainty around procurement targets and greater demand to revise nominations after the next day gas day. So if there's more demand to revise those nominations, we expect a greater need for flexibility to reflect those costs. Also, we're proposing a configurable fuel region parameter. This is a resource-specific adjustment that can give resources more flexibility based on observed systematic differences. If, for example, you are at a bidirectional pipeline and historically you've purchased fuel that does not correlate well with that gas hub, the ISO can assess your fuel purchase data and apply a new parameter to both your default and reasonableness thresholds to give you more certainty regularly and more flexibility to request cost adjustments. We've gotten stakeholder feedback that there's some interest in understanding how tools for use-limited resources play into this. So I quickly wanted to point out that tools for use-limited resources are not standard procedure for reflecting gas supply availability. A scheduling coordinator has to obtain use-limited status to use tools for use-limited resources. And you do that through registration and validation, and that requires a demonstration of certain criteria that are not typically applicable to gas supply limitations. For example, if your starts, run hours, or output are limited to design considerations, environmental restrictions, or qualifying contractual limitations, usually we see these types of things applied to noise ordinances or something like that. Also, the market process does not recognize the limitation. So if you submit an outage card, the market process does recognize the limitation. Hours of operation do not depend on an energy source outside of the resource's control. Some of the tools that are available to use limited resources include applying an opportunity cost to start up transmission and min load. These are typically calculated annually, so it's something that's not captured in a 24-hour operational day. Any questions about that? Okay. All right. Gotten to the end of this section. Stakeholders recommend that the ISO consider market-based approaches to manage gas system limitations more efficiently. And we understand why this is. Gas system limitations can affect a group of resources, not just an individual one. I also understand that an outage card is not the most efficient tool in the universe, but and we agree that conceptually a market-based approach can result in more efficient dispatch and transparent price signals. That all sounds great. But we've also learned from prior efforts that developing a feasible market design that reflects the intent of the gas pipeline and satisfies regulatory precedent is not without challenges. And this is largely because the ISO's expectation and rules around market participant behavior depend on the expectation and rules of the gas pipeline. So developing any new rules will require careful consideration of the gas pipeline's tariff and expectations. We also understand that as a concept, a gas nomogram would have broad appeal because it is a grouped constraint that can be designed to optimally allocate gas usage across impacted resources. The ISO's gas nomogram constraint is one of the tools available to ISO operators to reflect anticipated gas system limitations. And it is valuable and applicable, but under a precisely defined set of conditions to avoid a reliability event. And so in the next section, we're going to talk about this. The ISO does support making this tool available where applicable, and we want to make sure stakeholders understand how it relates to their preferred solutions. So I will move on to the next section where we talk about nomograms, and I'll get a couple of other subject matter experts on board. Before I do, any questions about expected behavior?
I'm not seeing any questions coming in at this moment.
Great. Well, just as a reminder, if you want to reach out and educate us about the unique rules of your pipeline and the different ways that you experience gas system limitations, Sean and I are all ears. So let's move on to using a gas nomogram constraint for reliability. The ISO's tariff narrowly defines authorized use of the gas nomogram constraint for specific gas regions and under certain conditions. Specifically, our tariff section 27.11 says the ISO may enforce a gas constraint for Southern California Edison and San Diego Gas and Electric. And we'll dig into the specifics of the operational procedure in a moment. The ISO does not currently have a standard process or set of guidelines for extending the use of a gas nomogram for other EIM or EDAM BAs. Any market participant interested in making use of a gas nomogram procedure must go through a rigorous process, including a public stakeholder process to propose, design, and vet the policy. This also means that any market participant interested in making use of the existing gas nomogram procedure, exactly as it was approved for SoCalGas and SDG&E, would also have to go through a public stakeholder process to vet the policy, even though it exists and is practiced today. So as the market operator, we want to make sure that all of our tools can be leveraged where applicable and valuable. So the ISO does support creating a streamlined process to allow EIM and EDAM BAs to make use of the existing procedure. FERC did previously reject the ISO's proposal to expand the use of a nomogram to the EIM. In doing so, they didn't exactly specify the precise procedural expectations for the one right or successful policy for a gas constraint nomogram. They did approve the procedure that we have for SoCalGas and SDG&E and posed a number of questions around the process for developing and informing a constraint in a different way. But because we have an approved design, that means that we are confident that the way we do it today is consistent with regulatory precedent. The way we do it today might not be the only right answer, but doing it differently is going to require answering a bunch of questions through the stakeholder process. So in this part of the workshop, we'll be doing two things. First, deep dive on the existing guidelines and operating procedure that the ISO uses to implement the FERC-approved rule around the gas nomogram. One of the things that we did not do last time around when going to FERC to request an extended use of this was establish specific guidelines and specific operating procedures up front for regional BAs. Now, there are reasons to this, but this time around, we do plan to support this proposal with a set of guidelines that align with existing procedure. And the other thing we're going to do is try to answer some of those regulatory questions that I mentioned to set the stage for thinking about other ways to go about using a gas constraint nomogram for those that are interested in doing so. So first, we'll talk about how this works today. This is a high-level overview of how the ISO implemented the gas nomogram for SoCalGas and SDG&E. Point number one that is very important is that the gas company is the entity that makes all the calls. The ISO maintains a nomogram for a zone that is specified by the gas pipeline under conditions that are specified by the gas pipeline, and the constraint itself is defined and informed by the gas pipeline. The ISO activates a constraint to avoid triggering a reliability event that might otherwise require manual gas curtailments to ensure gas system reliability and would otherwise require manual dispatch by the ISO market operator to ensure electric system reliability. So the nomogram exists in scenarios when we can't necessarily rely on standard practice. In other words, where market participants managing constraints themselves may not be sufficient. And also to avoid excessive impacts to the gas system under constrained conditions when bids in the electric market can't completely ensure reliability. So in these conditions, a nomogram could be incrementally better than manual dispatch and curtailment. It's not the only tool, but insofar as the gas pipeline recognizes that or identifies this as operating procedure, then the ISO supports designing and implementing the nomogram. And now I'm going to pass it on to Sean to talk about the steps for coordination and coming up with the nomogram procedure.
Thanks, Sylvie. Yeah, so here I'll talk about how, if a situation arises that requires a gas nomogram, it's going to be collaboration between the market entity, the gas pipeline company, and or the ISO, right? From there, the gas pipe company will engage the ISO or us so that all three parties kind of work together on putting this together. The real goal here is to find the specific need for the operating procedures that's different from what we've expected under normal conditions. So here it's really the market entity talking to the pipeline talking to the entity, and the ISO talking to everybody. So everybody coming onto the same page to figure out why this is a need. Next slide, please. But we also have to remember that the gas company is the one that defines what qualifies as a gas system reliability event, and they have to do that within their tariff, right? The gas nomogram comes into play when a gas system reliability issue can't be managed by other standard actions. So this is where the gas, as Sylvie said earlier, the gas company is the one that's running this or setting this off if it's needed. And they have to define what events are going to be applicable to these the use of the nomogram. We have to know that the limit in a nomogram must be clearly defined in the constraint. Once the nomogram is activated in the electric market, it impacts all generators on the effective pipeline for the duration of the event. So once the gas company has said, hey, ISO, can you please activate this nomogram? They've already set and defined what's within that nomogram, those units that are going to be impacted, and those units will be under that constraint until the nomogram has ended. And the gas company will be setting those parameters on the time duration of when the nomogram, the dates and times. So that's kind of a high level of anybody. Michelle.
I question, when we're talking about this nomograms, is it mainly being designed and looked at from a SoCal gas pipeline tariff? Because there are pipes that don't necessarily call curtailments or OFOs. What they will do, however, is they'll target specific end users that are causing the reliability issues on the pipe. So it's not like a system-wide curtailment, but they could curtail specific end users. And this is more for pipes outside of California, which I think one of the biggest challenges with EIM and EDAM is that this market goes across multiple pipes. So the design and the solutions that get presented can't need to be identified from outside just the SoCal gas system.
So I guess what you're saying is the way the SoCal gas is set up currently is they have different zones. They have their whole territory, then it's broken up into north-south, and then from there it's even broken down further. But it sounds, what you're saying is if we go outside of California, there's pipelines that go through multiple BAs that feed multiple generators that could potentially impact. Is that kind of what I heard?
Yeah, and I'll put out the pipe that I'm specifically referencing because it calls out under tariff. Is a Kern River pipe. Kern River does not call OFOs, and they don't necessarily call system. It's very rare that they call system-wide curtailment. However, if they have a high or low pressure, let me reference the high pressure. What they will do is they'll look at all of their generators and their customers, and they will curtail specific customers. And it's driven, that operational decision that the pipe makes is driven by the customers that are the ones that have caused the most reliability issues leading up to that high pressure. So it's not a system-wide, so it's a little bit more challenging to be able to manage and balance and maintain the reliability of the pipes, because sometimes, although in a perfect world, the fuel management would be done through the bidding strategy, it doesn't always materialize through the bidding strategy.
Understand. Okay. Yes. So that would be a little bit. So in that circumstance, and we do have a relationship with Kern River, and they do. You're correct. They will actually call the individual generators themselves and say, "Hey, you're out of imbalance. Can you get back in line?" Right. So everybody's different. So that's where the collaboration comes with the different BAs or market entities, where they would work with those gas companies, and if it's not feasible, say it's for like Kern River, for example, then there would be no nomogram probably potentially put into place. But say I'm
Yes.
just going to use Williams or TC. I'll use TC Energy. They have a few different pipelines that they're feeding generation on, where they could break that up potentially and create a nomogram depending on what zone or areas that they wanted, right? Depending on what their tariff is or what their current practices are.
Yeah, so from somebody who, from like a market participation standpoint, and having reservation rights on across multiple pipes, I think the limitations and the concern from the gas generator side is that when we look at SoCal, it's a lot more straightforward because there's a lot of measures and metrics where they declare the stage. If it's higher reliability issues, they increase the stage and then they'll go straight in curtailment. But the other key component there is that in order to avoid the exposure economically, there's an imbalanced market that no other market has. So when you get dispatch futuristic in EDAM and those awards don't materialize and get offset in EIM, you're dealt to have to balance and maintain the reliability in real time to not only maintain the reliability, but to remove that exposure of potentially having to lose money on the gas side, selling it off to reduce the pressure, or having to buy in real time. And I think the concern here is not just the California market, it's a larger footprint across multiple pipes and constraints and limitations.
I think, Michelle, what you're raising helps define an important point here, which is that a gas nomogram might not be the appropriate solution for all gas limitations or reliability events. One of the things that Sean does is help coordinate unique procedures for between the gas pipeline and the ISO market operator that might look different from the gas nomogram in different situations. And the question at hand here is this gas nomogram, as we have it defined today, and as we define, specifically designed for SoCal gas reliability issues, is this applicable for any reliability issues that might arise regionally? And it sounds like what you're describing may have other tools that are valuable as well. Am I capturing that well?
Silas, could we bring Michelle back?
Michelle, if you could please raise your hand so I could unmute your line, please. Thank you so much.
Yes, I think ultimately it's not like a one size fits all, and it might not be the solution for all gas resources.
Yeah, totally agreed. Which is why there's opportunities to develop other solutions on the table. Our goal right now is to help you understand what those options are and whether the gas nomogram is applicable. So hopefully that clarified for you how this might be applicable in your BA. But I'll hand it back to Sean to keep talking about it.
Thank you.
No, thank you for that comment, Michelle. I really do appreciate that. Because again, every circumstances is different. And as we go through this process, there's stuff that we may not have thought of that just rears its ugly head, but at least we want to set the foundation on how we want to move forward. And really it's getting that relationship with your gas company that's serving you to have those conversations and see what works and what doesn't work going forward. I think that's all, unless I have another slide there, Sylvie. And if anybody else has any other questions. Oh, yeah, sorry. That's right, 4120. All right. Let's try to pass it off to you, Sylvie. But no, operating procedure 4120, I'm sure everybody's read it. I'm just joking. But it basically lays out all the roles and responsibilities that each entity has. But the number one step is, again, the gas company is the one that is initiating the call when this procedure does get put into place. They're setting out the parameters. They're letting us know exactly what the limitations are, how long they're going to be, what zone it's going to be, right? So they lay out all the whole communication plan, and then internally we have our steps that we need to do. That's really all of 4120 rolled up nice and neat for everybody. But we also have currently with Kern River, PG&E Gas, and SoCal Gas, we have NDAs so that we can talk back and forth. And there's also FERC Order 787 allows us to talk back and forth, but we do have as well as an NDA with each of those entities. Now I think that's the last one, Sylvie.
Thanks.
If anybody's got any questions regarding that.
Oh, yeah.
I'm not seeing any questions at this time.
Cool. Thank you all for your time. I appreciate it, but I'm here.
I'm also pretty sure that Operating Procedure 4120 is a public document. So if you want to search CAISO Operating Procedure 4120 and read all about it, that is available to you. And when we get to the part where I talk about the gas resource management proposal, I'll mention this again. Our goal with the gas resource management proposal to make the gas nomogram available is to make sure that whatever operating procedure is being requested is consistent with operating procedure 4120. And this is because we're not trying to create complex or duplicative steps for our market operators around the gas nomogram constraint. So Sean just walked you through getting all of the proper entities to the table to come up with the need for a nomogram constraint. Next, I'll talk about what the ISO does. So the ISO will set up a constraint for a zone that's specified by the gas pipeline that limits the market optimization to dispatching no more than a specified amount of gas that is specified by the gas pipeline. The zone to resource mapping ensures that the gas constraint is appropriately applied to the resources that are impacted by the limitation. And again, this is something that is defined by the gas pipeline, and it could be a subset of resources or a broad regional area. The ISO will enforce a nomogram, ideally in 3 market runs: day ahead, real-time pre-dispatch, and RTD. If the ISO does not get the limitation in time from the gas pipeline before the day-ahead market runs, it may not be feasible to enforce in the day-ahead market. Now I'm going to talk a little bit about the formulation of the gas nomogram constraint that the ISO has used to date. I do want to point out that there may be other ways technically to inform what a gas nomogram constraint looks like in market design. At the end of the day, we will formulate a gas nomogram constraint in a way that satisfies the reliability concerns of the gas pipeline. So the gas pipeline is the one that's really dictating and determining what this design looks like. This is what we've used to date. I'll go a little bit into the technical details in the formula. If you have questions and you want us to explain this further, I think I've got Abhishek and Danny Johnson on the call to help me out with that. And you can also find this in the ISO's BPM for managing the full network model in section 4.2.7.1.2. So there's 2 sides to this formula. On the left-hand side, we define the constraint or the impacted zone that's identified by the gas pipeline. So the left-hand side notes a set of resources and defines their capacity in terms of MMCF per day. On the right-hand side, we've got the gas capacity reduction limitation. And this is the limitation on that generation, and it distributes a daily gas limitation across hours, basically by a shaping factor if it needs to be shaped. So looking at this in a little bit more detail, here's the left-hand side of the equation. You've got a set of generators in an effective area that is identified by the gas pipeline. the megawatt output of those generators, and we convert that to MMCFD using a gas conversion factor. This is a single average heat rate that we calculate from the master file. The right-hand side, this is the gas capacity reduction limit. So you've got the amount of generation that expressed in MMCF per day that the ISO determines is necessary to manage the gas system limitation and operate the electric system reliably. And then we have this allowance distribution coefficient. I think of this just as a shaping factor. So if we get an hourly limit from the gas company, we can apply that directly. If it's a daily limit, we'll want to shape that throughout the day to use the limited gas efficiently. So we might do that by shaping it based on a ratio of net load forecast to daily net load forecast. We might also use the last available D2 gas burn as a reference. Again, there's different ways to do this, but this is what we have used in the past. Now the impact of this. When the constraint is applied in the market, it is enforced and binding. It lowers resource-specific LMPs in the gas-constrained area so that there's an economic signal to ensure gas usage is appropriately managed. And I just want to point out that this is a distinct approach from what we've been hearing from some stakeholders, where a resource might increase its energy offer in order to avoid being dispatched. This lowers LMPs in the area to prevent resources, as their energy offer is, from being dispatched, and it'll force the optimization to find supply from somewhere else. I do want to note that nomograms, gas constraint nomograms, will be active during the EDAM RSC. The purpose of formulating it this way is to support gas system reliability while also limiting distortions to market outcomes in the electricity market. When active in binding, the shadow price of the constraint will be reflected in the congestion component of LMPs of only the affected resources. Or more technically, what you'll read in our documents is that at nodes used to dispatch associated generators with a shift factor of 1. So that is where the price signal shows up. The shadow price will not be reflected in the marginal cost of congestion for LMPs for cleared demand. In other words, it will be applied with a shift factor of 0 to all other pricing nodes that are used to settle demand. So that was all of the technical aspects of how we formulate this and how we do this at the deference of the gas pipeline company. Finally, I do want to discuss the fact that the use of the gas nomogram has some practical considerations. For example, setting up the constraint is a manual process that requires a lot of coordinated communication. I also mentioned that the heat rate we use is a single average heat rate that we pulled from the master file, which makes it somewhat less precise than if we use the full heat rate curve. But we do that to simplify the equation, which is already computationally intensive. Nomograms in general are computationally intensive to run within the optimization, and this is why the ISO monitors and manages the volume of active nomogram constraints to make sure we have robust market performance while supporting system reliability. And all of this is to say that in practice, there are a lot of complexities and considerations around the use of a gas nomogram for reliability, and it is just one of many tools the ISO uses to maintain reliability. Back to Michelle's point, it may not be the right or the applicable tool in some situations. It is important in some situations. And to illustrate that, I'm wondering if Mashir or Abhishek are available to talk to us about when we've used this in the past.
Yeah, it's me here. I can talk to it. Thanks, Sylvie. Okay. Yeah, I wanted to share exactly some of the data that sort of shows when the nomogram was activated, and then there's also going to be some data on when it actually bound. And this slide is showing for the last 6 years, starting January 2019 until July 2025, on the percent of intervals by month where the gas nomogram was activated or enforced. And the data shows that the gas nomogram that covers this is the existing gas nomogram that covers the zones of SoCal Gas and SDG&E, was enforced in 2020, 2019, 2020, right around the post-Aliso Canyon period. But since then, it hasn't been enforced much at all. I think that's pretty much the takeaway from this slide. Yes, next slide. Okay, so this showing not just when the nomogram was enforced or activated, but also when it bound, meaning when the limit of the constraint was actually reached. Then, as expected, it wasn't reached frequently. That's the color in red, while the color in green was the same as the previous slide, just the percentage of intervals when the nomogram was enforced, and the red is when it was bound. This is not a stacked chart, so the percentage of enforced on this slide is the same as what it was on the previous slide. Is just showing the percentage of the total in red that bound, where the nomogram bound.
So enforced and
Okay.
bound.
Yes.
Yeah.
Exactly. Bound means it was enforced and it also had then bound. Precisely. Thank you. Okay. I think that's all I have. And
Yeah.
I'll say also, you know, this is for RTD market, but similar data. We see similar trend in the other markets, IFM as well as in RTPD. And yes, I should also mention, okay, we see that this nomogram was enforced, but it didn't bind in most recently in May 2025. That was due to some gas outages in the San Diego gas and electric region. Yeah. Thanks,
Thank
Sylvie.
you, Mahir. All right, we are going to move on to talk about what it means to develop guidelines for extending the use of the gas nomogram as a reliability tool broadly across the market footprint. And as part of that discussion, one of the things I'll mention is that our expectations for the gas resource management straw proposal is that in extending the use of the gas nomogram, we want to create a streamlined process to avoid having to have multiple stakeholder processes around the same procedure. So our expectation for the gas resource management straw proposal is that a requested nomogram would look like what we just talked about, from the coordination to operational procedure 4120. These would be our expectations. So are there any questions about that? And if not, you can always reach out to us to learn more if this is something that you think is important to you.
Not seeing any questions at this time.
Okay. So let's move on to opportunities for EIM or EDMBAs to implement a gas nomogram constraint procedure. I just mentioned that in the straw proposal, the ISO is proposing to offer a streamlined process to make the existing operating procedure, what we just talked about, available to all market participants for whom the predetermined conditions apply. I also mentioned earlier that the last time the ISO asked for FERC approval to extend the nomogram. It was rejected, and they posed a couple of questions absent more details around the operating procedure. So to support this proposal, we are going to define a set of guidelines and procedure in order to expand its use. Insofar as stakeholders are interested in developing a different procedure, stakeholders will have to consider questions that FERC raised in response to the ISO's prior effort. And to kick things off with that, to open the door to that discussion, I have Andrew Ulmer from our legal department here to talk about some of those questions. Andrew?
Hi, Sylvie. Good morning, everyone. Hopefully you can hear me.
Yes, we can.
Great. Okay, I've just got 2 or 3 slides to walk through, and I think Sylvie framed this accurately, which is that we have some lessons learned from efforts to expand the use of a gas nomogram, which we proposed to do back in 2017, both within the entire ISO BA, as opposed to just in connection with the SoCalGas and SDG&E systems, but also into the WEIM area as well, and provide sort of a means for BAs operating in those areas, EIM entities, to inform the market of gas constraints that impact the dispatch of generating resources. So we made that proposal in 2017 in conjunction with a number of other proposals seeking to make some of the mitigation measures we had in place on an interim basis more permanent, and those mitigation measures associated with the constraints associated with the Aliso Gas Canyon, facility. So I see folks on the call who probably lived through this as well, and you'll recall that the Federal Energy Regulatory Commission rejected sort of the suite of permanent measures and also raised a number of questions, included a brief citation to the order here. So it should be very easy for folks to pull up and they can look at it. I think the questions are included toward the end of the order, starting around, I think, paragraph 55. So for reference, folks can take a look at that. But generally, the questions fell into several categories, and one was seeking to sort of understand whether or not if balancing authorities in the WEIM had the ability to develop and enforce a gas constraint, would that have some kind of undue influence on market operations, understanding that the BA function that those entities performed was simply one function. They also might be generator owners, transmission operators, and the commission asked a number of questions about whether or not employees with a marketing function for WEIM entities, and if we think about it now in the context of EDAM, I guess the same question would be in play. Would they somehow have access to non-public information about transmission system operations? And if they would, how would they? It's an interesting question. I'm not sure I have an answer to it, but it's one that I think we would want to overlay on any effort to extend the use of a gas constraint nomogram. And to the extent that they apply to the question here applies to WEIM or EDAM entities that somehow apply to the ISO and its role as a BA, it would not seem to, given that in this space the ISO is solely a market operator, doesn't own facilities, and I suppose one question that arises is if the market operator, if the ISO, as opposed to a WEIM BA or an EDAM entity BA, were the entities that worked with the gas pipeline or local distribution company to develop this maximum gas burn constraint, or what the constraint was and how it was configured. Would that alleviate some of these concerns if that coordination occurred between the ISO and the gas entity? So that was one set of slides, and maybe we can go to the next slide, that one set of questions. So there are a number of questions about, whether or not the constraint would only reflect physical limitations. I think that's what we had proposed back in 2017. But that does beg some questions, I suppose, as we think about extending its use, and that is, the Aliso Canyon constraint was, quite significant when it was in play. And what other constraints, if you will, exist on gas pipelines in the West? What other constraints do local distribution systems face? Are there physical constraints that are so material that they would merit developing some type of nomogram for use in the electricity markets? And then a number of questions about, well, how would the mechanics of the process work, which I think Sylvia sort of begun to pull the string on in earlier slides. But how would we coordinate enforcement? Could the constraints exist for purposes other than physical constraints? Could there be a regulatory directive, for example, or some other reason that we should acknowledge is similar enough to a physical constraint that we should be enforcing it in the electricity markets? And then how do we monitor that constraint? How do we revisit it? These are questions about, is it a constraint forevermore, or does it evolve based on system conditions, new infrastructure, et cetera, et cetera? So there are a series of just sort of questions I think we have to reflect on as we embark on any effort to extend a gas nomogram constraint. And then I think there were maybe just one other slide, I think. This was a question that related, I think, to the WEIM area, given that some resources in the WEIM area are participating in the market, some are not. So if we were to apply a market constraint to those that are participating, would that ultimately solve the problem for the gas pipeline or the local distribution company? It might not, but I think that was the question, which is this really going to be effective if you're only applying it to a subset of resources that are drawing on the gas pipeline? But a question, is, maybe if we had deeper coordination between the market operator, between the gas pipeline and the LDC, would that address this question in a sense that the gas pipeline would understand more of the inputs into those resources not participating in the market versus those that were? This question might be less relevant in the context of EDAM when you have all resources in, as opposed to participating resources and non-participating resources. And then I think Sylvie mentioned this, that our expectation is that the gas constraint would be enforced in an RSC situation, but it does, some of the questions that did come out of that FERC order did involve questions about how would that work, and would it avoid sort of the risk of other manual interventions? For instance, if we're running processes that don't acknowledge the constraint, are we then going to have to have some kind of operator engagement in our market runs when that constraint is enforced? And that could be, by way of example, I suppose, a market power mitigation run or actual real-time dispatch. So I think that the commission was asking, are we trying to solve one problem and creating new ones? But again, these would be, generic questions that we would want to overlay on any effort, and to the extent they remain relevant, certainly answer any kind of proposal that we make that's seeking regulatory relief or authority to proceed. So I'll stop there, see if there are any questions or discussion from folks.
I'm not seeing any questions coming in at this time.
And I mean, I would say, you know, folks are going to submit any kind of written comments, answers to these questions, ideas about them. To, you know, we're open and would very much appreciate any thoughts and input.
Thanks, Andrew. Always asking the hard-hitting questions. Well, that leads us to the proposal that we have. Oh,
we actually just
sorry.
got a question from Colin User 4. If you could please state your name and affiliation before asking your question, please.
Great, thanks. This is Christopher McLean, staff at the California Energy Commission. A quick question for Andrew. And this may have been addressed in one or more FERC filings, and I might have missed it, but have any of the market efficiency enhancement agreements, the sort of one-offs with specific sort of service counterparties, have any of those implemented gas-related constraints that, you know, could look like a nomogram? This I ask in you know, the sense that to the extent ISO's had some experience with implementing these on other parties' systems, that could be of interest to share with the group.
Hey, good to hear from you. I'm not sure I totally caught the question. And maybe I'll restate it and tell me if I get it right. Was it that whether or not any of the agreements that the ISO has with other balancing areas recognize that a gas constraint might exist and might be utilized by that balancing authority to inform market operations?
Yeah, so I think so this is sort of a narrow subset. So particularly there's, you know, some collection of MEEAs with other entities where CAISO's performing the service of sort of optimizing their system. And so the ask is, you know, have gas constraints or similar sort of been developed and sort of implemented or employed in the provision of that service.
Right. Yeah. Yeah, I think the agreements you're referring to, the market efficiency enhancement agreements, or I have to say the acronym MIA, these were agreements developed kind of in concert with an earlier modeling approach we took for dealing with the interconnectedness between the what is now bank and the ISO system. And those enhancement agreements involved the exchange of data for more accurate modeling of sources and sinks on those systems. So instead of assuming that the source was coming from some default location, by the exchange of information, we were able to, you know, more precisely model both the sources supporting interchange transactions and the sinks supporting interchange transactions, which created arguably more accurate LMPs. But I don't believe they addressed in any way any kind of gas constraints or natural gas constraints, say on the PG&E system, that may have informed dispatch of units in the Balancing Authority of Northern California. So I hope that's helpful.
Yeah, that was helpful. Thank you, Andrew. And I guess the other sort of use case is maybe I think that service has been provided in the past for Pacificor, so whether or not their system was, you know, featured that sort of approach, that could be interesting as well.
Again, I mean, there are some. There is something a service we perform that is utilized by Pacificor to provide nodal prices and kind of an advisory basis that's used for other purposes. I do not believe that agreement involves any kind of enforcement of a gas constraint.
Excellent. Appreciate the feedback. Thanks, Andrew.
Okay, no worries.
And I'm not seeing any other questions coming in at this time.
Okay. Well, great. In that case, we'll start to wrap up here with how all this plays into the gas resource management straw proposal, where we are proposing to create an expedited process to leverage the existing functionality that Sean and I talked about earlier. So the ISO is proposing to generalize the tariff language in section 2711 to allow coordination between the ISO and regional service areas or BAs outside of SoCalGas and SDG&E. And in doing so, this gives market participants an opportunity to leverage the existing design and procedure without having to go through a full stakeholder process if the guidelines for doing so are met. And this is intended to make sure that the tool and the procedure as it exists today is available for the regional market footprint if valuable and applicable. This proposal does not intend to, or does not, modify anything about the existing procedure or how we implement it. And it's not intended to open the door for market participants to discuss modifying this procedure without vetting those changes in a stakeholder process. We are absolutely open to talking about a different way of doing this. As I mentioned, there may not be one right answer, but thinking about other formulations will require answering Andrew's questions. And you may also want to consider other considerations that we've talked about today. For example, the practical challenges associated with the nomogram. Other options may be more efficient. The gas nomogram constraint as something that's computationally intensive may not be feasible or effective to use as a daily limitation. And you can always reach out to us and work with Sean's team to come up with other operating procedures to ensure system reliability. So there are a lot of options and avenues on the table for whatever scenario you have in mind. And the gas and the proposal at hand is just for this operating procedure 4120. So to support the proposal in the straw, we wanted to provide these guidelines for eligibility for the expedited stakeholder process. And the intent of these guidelines is to make sure that whatever procedure is being requested, it aligns with what FERC has already approved and would not require additional vetting through the ISO's stakeholder process. So this is a signal to FERC and regulators that what we're doing complies with expectations, and it is also a guideline for stakeholders to determine whether this process is appropriate for you. These are draft guidelines, and we've summarized these in the straw proposal, open to stakeholder feedback on this. Number one, our expectation is that you establish a relationship between the electric entity responsible for liability, so that would be the BA, and the gas entity, which would be the gas pipeline operator. Two, we expect that jointly they would show that there is a gas system limitation that can impact electric system reliability. Three, they would jointly show that a gas constraint nomogram is needed and necessary to reflect a gas system limitation in the market optimization. And finally, we would expect that they would jointly engage with the ISO market operator to confirm that the requested procedure is consistent with existing standards that we describe in Operational Procedure 4120. And I think this is my last slide. So you all have made it through our crash course in nomograms and managing gas system reliability. We have a little bit of time left, so I'm happy to open it up to questions or anything that you want us to revisit.
Not seeing any questions coming in. Just a reminder to folks, if you're having trouble raising your hand, you can always send in your question via chat as well. Still not seeing any questions coming in. Sylvie, did you want me to take over for next steps?
Yeah, great. Thanks, Christina.
Thanks, Sylvie. I just have a couple of next steps and announcements before we wrap up for the day here. A comment template will be up soon, and comments will be due by August 26th. Meeting materials are available on the initiative webpage linked here. And if you have any additional questions that come up that you didn't get to ask today, feel free to reach out to us at isostakeholderaffairs@kaiso.com. Now I just have a few announcements before we wrap up for the day. Here you can see some of the meetings taking place at the ISO this week, as well as comment submission deadlines and a training. And lastly, here you can see market simulation meeting information and instructions. And lastly, for insights into the ISO grid and market operations, be on the lookout for our Energy Matters blog, or you can always subscribe. Here you can see our latest blog post regarding exploring AI to support smarter grid management. And so with that, we'd like to thank you so much for joining today's discussion. As a reminder, this meeting was recorded for information and convenience purposes only, and all meeting materials will be available soon online, and the video file will be posted soon. We thank you very much, and we hope you have a wonderful rest of your day. Thank you.